Let's describe virtualization concepts. In this case, we're going to talk about Vxlan. Vxlan means a virtual extensible LAN. It will help us communicate devices that belong to the same broadcast domain and are connected to different network devices over a layer 3 underlying network using tunnels. In order to identify traffic, Vxlan will use VNIs, that means virtual network identifiers. It will encapsulate Ethernet frames using an IP header, UDP header, and a Vxlan header. The actual devices that will be creating the tunnels will be known as VTEPs or virtual endpoints. You can have a software-based VTEP, for instance, a virtual switch running over a hypervisor. The Vxlan header includes flags and a VNID that is 24 bits wide. The valid range for VNIs is this. You cannot use this range. The header formats can change a little if you're using the Cisco SD Access framework. So first you will have to configure the underlay. That can be ISIS, OSPF, or in rare cases, EIGRP in order to advertise the loopbacks of all devices. Then you will have to configure your data plane. So the data plane will do the following. If server 1 wants to send a frame to server 2, it will send a normal Ethernet frame into VTEP. Then VTEP will encapsulate that traffic and will send encapsulated traffic into VTEP 2. Then VTEP 2 will de-encapsulate that traffic and deliver a normal frame into server 2. So the question here is how VTEP 1 knows that it has to send this traffic to VTEP 2. That is where the control plane kicks in. So you have to choose which control plane you will be using. You can use multicast, which is very good to send ARP request. You can use unicast, you can use multi-protocol BGP with the address family layer 2 VPN, EVPN. In this case, BGP learns MAC addresses. Or if you're using, for instance, the Cisco SD Access framework, you will be using Lisp. In order to configure Vxlan, you first will have to map your VLAN IDs to your VNIs. You can use the VLAN configuration mode and you can establish that mapping there. Then you have to configure Network Virtual Interface or MVE, where you will be mapping your VNIs to multicast groups. So here you will be mapping each VNI to a different multicast group. Remember that in order to use Vxlan, you will have to use multicast for your ARP request. In this case, your rendezvous point will be your spine switches. So if you had another spine, for instance, that other spine will be a rendezvous point. The rendezvous point's IP address will be the same, so you will be using Anycast rendezvous point. Remember that this device believes that this other device exists in the same broadcast network, and they have broadcast domain, and they have the same default gateway. So you will have to configure SBI here and an SBI here, and at each VTEP you have to configure an SBI using the same default gateway IP address. So you will be using a default gateway Anycast. The rest of the configuration depends on the control plane you're choosing. If you're using BGP, you will need some configuration. If you're using Lisp, you will need another configuration. If you're using unicast, you will need other configuration, not shown here. That's it.